Romex, also known as non-metallic sheath cable or Type NM cable, is generally not permitted for use in high-rise buildings, specifically those with 20 or more floors. The National Electrical Code, or NEC, outlines specific requirements for wiring methods in different types of buildings to ensure safety and prevent fire hazards. For vertical runs of electrical wiring through multiple floors in commercial and industrial buildings, the NEC mandates the use of more robust cable types that offer better fire resistance and mechanical protection compared to Romex. NEC Section 334.10 restricts the use of NM cable in Type 1 and Type 2 construction. These construction types typically encompass high-rise buildings due to their size and occupancy. The primary reason for this restriction is the potential for fire to spread rapidly through vertical shafts and concealed spaces in high-rise structures. Romex, while suitable for many residential applications, is not designed to withstand the rigorous demands of these environments. The NEC specifies two main alternatives to Romex for vertical cable runs in high-rise buildings: firstly, metal-clad cable or MC cable, and secondly, mineral-insulated cable or MI cable. MC cable consists of one or more insulated conductors enclosed in a metallic sheath, providing enhanced mechanical protection and fire resistance compared to Romex. The metal sheath acts as a barrier against physical damage and helps to contain any potential fire within the cable. NEC Article 330 covers the requirements for metal-clad cable. MI cable, on the other hand, is constructed with copper conductors insulated by a mineral compound, typically magnesium oxide, and encased in a seamless copper or stainless steel sheath. MI cable offers exceptional fire resistance, high ampacity, and durability, making it suitable for critical applications and harsh environments. NEC Article 332 covers the requirements for mineral-insulated cable. The choice between MC cable and MI cable depends on the specific requirements of the installation, considering factors such as cost, opacity, voltage drop, and environmental conditions. MC cable is generally more cost-effective and easier to install than MI cable, while MI cable provides superior performance in terms of fire resistance and durability. When designing and installing electrical systems in high-rise buildings, it is crucial to adhere to the NEC requirements and consult with qualified electrical engineers and contractors to ensure compliance and safety. Ignoring these regulations can lead to serious consequences, including fines, project delays, and, most importantly, increased risk of fire and electrical hazards. In addition to the cable type, other factors to consider for electrical installations in high-rise buildings include the proper sizing of conductors, the selection of appropriate overcurrent protection devices, and the implementation of grounding and bonding systems to minimize the risk of electrical shock. The NEC provides detailed guidelines for these aspects of electrical system design and installation. High-rise buildings often have complex electrical distribution systems with multiple voltage levels and backup power sources. Proper coordination and selective coordination of overcurrent protection devices are essential to ensure that only the affected portion of the system is de-energized in the event of a fault, minimizing disruption to critical loads. Regular inspection and maintenance of electrical systems are also crucial for maintaining safety and reliability in high-rise buildings. These inspections should be performed by qualified electrical professionals and should include visual inspections, insulation resistance testing, and functional testing of protective devices. Furthermore, any modifications or additions to the electrical system should be performed in accordance with the NEC and under the supervision of a licensed electrical contractor. The NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. It is essential for electrical professionals to stay current with the latest edition of the NEC and any local amendments or regulations. Continuing education and training programs can help electrical professionals maintain their knowledge and skills and ensure compliance with the latest codes and standards. In summary, the use of Romex or NM cable is generally prohibited in high-rise buildings due to fire safety concerns. The NEC mandates the use of more robust cable types, such as MC cable and MI cable, for vertical cable runs in these structures. Adhering to the NEC requirements and consulting with qualified professionals are essential for ensuring the safety and reliability of electrical systems in high-rise buildings. The NEC is not just a set of rules, it is a comprehensive guide for safe electrical installations aimed at protecting people and property from electrical hazards. The code addresses various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. It is developed and maintained by the National Fire Protection Association, or NFPA, a non-profit organization dedicated to reducing death, injury, and property loss due to fire, electrical, and related hazards. The NEC is widely adopted by states and municipalities throughout the United States and serves as the basis for electrical codes in many other countries. It is a dynamic document that is constantly evolving to keep pace with advancements in technology and changes in industry practices. The NEC is organized into chapters, articles, and sections covering a wide range of topics related to electrical installations. Chapter 1 contains general requirements applicable to all electrical installations. Chapters 2, 3, and 4 cover wiring and protection, wiring methods and materials, and equipment for general use, respectively. Chapters 5, 6, and 7 address special occupancies, special equipment, and special conditions. Chapter 8 covers communication systems, and Chapter 9 contains tables and examples. Each article within the NEC focuses on a specific topic, such as wiring methods for specific types of cables or requirements for grounding and bonding. Sections within each article provide detailed requirements for specific aspects of the topic. The NEC uses a numbering system to identify specific sections and requirements. For example, NEC Section 300.4 addresses protection against physical damage. The NEC also includes informational annexes that provide additional guidance and explanations of the code requirements. These annexes are not part of the enforceable code but can be helpful in understanding and applying the code provisions. In addition to the NEC, other standards and regulations may apply to electrical installations in high-rise buildings, depending on the specific location and type of occupancy. These may include local building codes, fire codes, and accessibility standards. It is important to consult with local authorities and qualified professionals to determine all applicable requirements. The design and installation of electrical systems in high-rise buildings is a complex and challenging task that requires specialized knowledge and expertise. It is essential to work with qualified electrical engineers and contractors who have experience in this type of construction. These professionals can help ensure that the electrical system is designed and installed in accordance with all applicable codes and standards and that it meets the specific needs of the building and its occupants. Regular inspections and maintenance of electrical systems are also crucial for maintaining safety and reliability in high-rise buildings. These inspections should be performed by qualified electrical professionals and should include visual inspections, insulation resistance testing, and functional testing of protective devices. Any deficiencies or problems identified during these inspections should be promptly corrected to prevent potential hazards. In addition to routine maintenance, it is also important to have a plan in place for responding to electrical emergencies such as power outages or equipment failures. This plan should include procedures for safely shutting down equipment, restoring power, and communicating with building occupants. High-rise buildings often have sophisticated fire alarm and suppression systems that are integrated with the electrical system. It is important to ensure that these systems are properly maintained and tested to ensure that they will function correctly in the event of a fire. The NEC contains specific requirements for the installation and wiring of fire alarm systems. The grounding and bonding of electrical systems are critical for safety and for preventing electrical shock hazards. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures and equipment. Proper grounding and bonding can help to minimize the risk of electrical shock and can also help to protect electronic equipment from damage due to voltage surges or lightning strikes. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC provides detailed requirements for the selection and installation of overcurrent protection devices, including the ampacity rating of conductors and the interrupting rating of circuit breakers and fuses. Proper coordination and selective coordination of overcurrent protection devices are essential to ensure that only the affected portion of the system is de-energized in the event of a fault, minimizing disruption to critical loads. The use of arc fault circuit interrupters, or SIs, is required in many areas of high-rise buildings to protect against arc faults, which are a common cause of electrical fires. SIs are designed to detect arc faults and to quickly shut off the power to the circuit, preventing a fire from starting. Surge protection devices, or SPDs, are used to protect electronic equipment from damage due to voltage surges or lightning strikes. SPD are typically installed at the service entrance and at individual equipment locations. The NEC contains requirements for the installation and wiring of SPD. Energy efficiency is becoming increasingly important in high-rise buildings. The NEC contains provisions for energy-efficient lighting, HVAC systems, and other electrical equipment. The use of LED lighting, variable frequency drives, and other energy-saving technologies can help to reduce energy consumption and lower operating costs. The installation of renewable energy systems, such as solar photovoltaic systems, is also becoming more common in high-rise buildings. The NEC contains requirements for the installation and wiring of renewable energy systems. Electrical safety is a shared responsibility. Building owners, managers, tenants, and electrical professionals all have a role to play in ensuring the safety of electrical systems in high-rise buildings. By following the NEC requirements, working with qualified professionals, and implementing a comprehensive maintenance program, it is possible to create a safe and reliable electrical environment in high-rise buildings. In addition to the specific requirements for cable types, the NEC also addresses other aspects of wiring in high-rise buildings, such as the support and securing of cables, the protection of cables from physical damage, and the routing of cables through fire-rated walls and floors. Cables must be properly supported and secured to prevent them from sagging or becoming damaged. The NEC specifies the maximum spacing for cable supports. Cables must also be protected from physical damage, such as impact or abrasion. The NEC requires the use of conduit or other protective measures in areas where cables are exposed to physical damage. When cables pass through fire-rated walls and floors, they must be installed in accordance with the NEC requirements to maintain the integrity of the fire rating. This typically involves the use of fire-stopping materials to seal the openings around the cables. The NEC also addresses the installation of electrical equipment in high-rise buildings such as panel boards, transformers, and generators. Panel boards must be properly sized and installed to provide adequate overcurrent protection for the circuits they serve. Transformers must be properly ventilated to prevent overheating. Generators must be installed with appropriate transfer switches to ensure a reliable source of backup power in the event of a power outage. The NEC also contains requirements for the installation of lighting and receptacles in high-rise buildings. Lighting must be designed to provide adequate illumination for the tasks being performed in the space. Receptacles must be located in convenient locations and must be of the appropriate type for the equipment being used. The use of ground fault circuit interrupters, or GFCIs, is required in certain locations, such as bathrooms and kitchens, to protect against electrical shock hazards. The NEC also addresses the installation of communications systems in high-rise buildings such as telephone, data, and cable television systems. These systems must be installed in accordance with the NEC requirements to ensure that they do not interfere with the electrical power system. The NEC also contains requirements for the installation of fire alarm systems in high-rise buildings. Fire alarm systems must be designed to provide early warning of a fire and to initiate appropriate emergency response procedures. The NEC specifies the types of fire alarm devices that must be installed, the location of these devices, and the wiring requirements for the system. The NEC also addresses the installation of emergency lighting systems in high-rise buildings. Emergency lighting systems must be designed to provide adequate illumination in the event of a power outage. The NEC specifies the types of emergency lighting fixtures that must be installed, the location of these fixtures, and the wiring requirements for the system. The NEC also contains requirements for the installation of elevators and escalators in high-rise buildings. Elevators and escalators must be installed in accordance with the NEC requirements to ensure the safety of passengers. The NEC specifies the types of electrical equipment that must be used, the wiring requirements for the system, and the safety devices that must be installed. The NEC also addresses the installation of HVAC systems in high-rise buildings. HVAC systems must be installed in accordance with the NEC requirements to ensure that they do not overload the electrical system. The NEC specifies the types of electrical equipment that must be used, the wiring requirements for the system, and the safety devices that must be installed. The NEC is a complex and comprehensive document that covers a wide range of topics related to electrical installations. It is essential for electrical professionals to be familiar with the NEC requirements and to follow them carefully to ensure the safety of electrical systems in high-rise buildings. The NEC is not just a set of rules, it is a guide for safe electrical installations.